Okay, picture this. You're staring at your screen, watching your statistical software endlessly process, and then, boom, you're hit with a non-convergence error. It is literally one of the most frustrating things for any researcher, right? You've spent months meticulously collecting survey data. You've got dozens of observed items to make sure your measurement is absolutely comprehensive. But when you actually plug it all into your structural equation model, the sheer complexity of the parameters makes the whole thing just collapse under its own weight. It's a total catch-22. You want detailed data, but your model just cannot handle the heavy lifting. Well, welcome to this explainer on item parceling. This is a highly effective, though, yeah, sometimes a bit controversial technique that's used to simplify those complex measurement models, stabilize your estimations, and actually get your structural models to run smoothly. When you use this correctly, it's an absolute game changer for data analysis.
Here's a quick look at our roadmap. We're going to cover the core concept of parceling, the massive statistical advantages, the hidden risks you need to watch out for, the strict preconditions for safe use, and exactly how to apply it.
All right, let's jump right into section 1, the concept itself. So what actually is it? By definition, item parceling is a technique used mostly in SEM. It involves taking multiple observed items, think of these as the individual questions on your survey, and aggregating them into a smaller number of composite indicators, which we call parcels. These parcels then represent your latent constructs. Honestly, I like to think of this using a packing metaphor. Imagine you're moving to a new house. If you try to carry 100 individual loose books to your car, you're going to drop them. It's chaotic, it's inefficient. But if you pack those books into 3 sturdy moving boxes, the heavy lifting becomes so much easier. Parceling is basically packing your data into neat little boxes for your statistical software to carry. Just visualize it for a second. You've got a single latent construct trying to manage a bunch of observed items, say 10 different survey questions. Every single arrow there is a parameter the software has to estimate, which gets incredibly messy fast. But when we apply parceling, we combine those items by summing or averaging them. Now our latent construct only points to 3 parcels. It drastically reduces the complexity of the measurement model while still totally maintaining the core representation of your underlying construct. Okay, moving to section 2. Let's look at the actual advantages here because they are highly tangible. The statistical and practical perks of packing your data this way are honestly huge. Because you're dealing with fewer boxes, you're estimating fewer parameters. That immediately gives you improved estimation stability and way easier model convergence. Basically, your model will actually run. Plus, by aggregating items, you're effectively averaging out the random measurement error that's specific to individual questions, which bumps up your reliability. You also drop that pesky multicollinearity, when items are just way too correlated with one another. But honestly, the absolute favorite benefit for most researchers, the fit indices. Parceling often gives you a significantly better overall model fit. You're looking at higher CFI and TLI scores and a lower, much more favorable RMSEA. You are essentially boosting your statistical power just by improving your indicator to sample size ratio. But hold on just a minute. Before you run off and start parceling all your data to get those sweet fit indices, we need to talk about section 3, the criticisms and the hidden risks. This technique is incredibly powerful, which means it can be dangerous if you misuse it. So what's the dark side? Well, the absolute biggest criticism is the very serious risk of hiding multidimensionality. Let's say your construct actually consists of 2 distinct subfactors, dimension A and dimension B, but your model is struggling. If you just blindly lump items from both of those dimensions together into a single box, the resulting model might actually show an artificially good fit. But it's an illusion. You've successfully masked the true factor structure. You're literally just hiding the mess inside the box. When you do that, important theoretical distinctions are lost, the connection to your measurement becomes indirect, and trying to actually interpret your results becomes a huge problem. Which brings us to a really crucial warning, summarized perfectly right here. Parceling is not a remedy for poor measurement. It should absolutely never be used to fix a poorly fitting model. Look, if your survey questions are bad or your theoretical structure is flawed to begin with, parceling is just sweeping those fundamental errors under the rug. It is a tool for simplification, not a tool for salvage. And that leads us perfectly into section 4, the preconditions for safe use. How do we make sure we're actually using this responsibly? You absolutely need these 3 things before you can safely create a parcel. First up, unidimensionality. The items you're combining have to measure a single underlying dimension. And you need solid proof of this from an exploratory or confirmatory factor analysis. Second is high reliability. The construct needs a Cronbach's alpha of at least 0.70 to prove internal consistency. And third, theoretical justification. You can't just group items together arbitrarily. Your decision has to make logical sense based on your established theoretical framework. If you want to make this foolproof, you'll want to follow a really strict checklist. Start with standard item screening. Check for quality, normality, missing values. From there, run an exploratory factor analysis to make sure there are no hidden subdimensions lurking in the data. Follow that right up with a confirmatory factor analysis to absolutely lock in that unidimensional model. Finally, verify that your reliability hits that 0.70 mark. It's only after passing all 4 of these rigorous checks that you should actually create your parcels. All right, you've cleared the hurdles. Section 5, Methods and Application. Let's look at how you actually group these items. You basically have 3 main strategies to choose from. First is random assignment, which is exactly what it sounds like, just throwing items randomly into boxes. It's super easy, sure, but it produces unbalanced parcels with pretty low statistical quality, so it's our least preferred method. Next is the domain representative method, which groups items based on content subdomains. This one is situationally preferred, usually when your theory really emphasizes specific facets of a construct. But the absolute gold standard, the most recommended method, is item-to-construct balance. For this one, you look at the factor loadings of your items and you distribute the high, medium, and low-loading items evenly across your parcels. This gives you statistically equivalent parcels that represent your construct beautifully. Let's ground this with a concrete example. Say you're measuring customer satisfaction, and you've got 9 individual survey items for it. Managing 9 items for just one construct in a larger model is a headache. So, using that item-to-construct balance method we just talked about, we distribute the 9 items evenly. We take items 1, 4, and 7 and average them to create parcel 1. Items 2, 5, and 8 become parcel 2, and items 3, 6, and 9 become parcel 3. Just like that, we've successfully streamlined a clunky 9-item measurement down to a clean, highly reliable 3-parcel measurement. And this kind of simplification isn't just a neat trick. It's practically a survival strategy for large-scale SEM models. When you look at complex research in fields like tourism, marketing, or ESG, the models are massive. They're often linking half a dozen or more constructs together. If researchers kept everything at the item level, the models would just crash and burn. By applying item parceling, they reduce the number of indicators, radically simplify the measurement model, and finally get the stable, latent variable estimation they need to uncover those big structural relationships. So, to wrap things up, the big takeaway you should leave with today is this. Item parceling is a remarkably powerful tool in your statistical arsenal. It makes your models efficient, it makes them stable, and it makes them much easier to interpret. But that power means it demands careful judgment. You cannot use it blindly. You absolutely must have strong theoretical grounding and proven unidimensionality before you start packing your variables.
So, as you go back to your own complex datasets and consider the models you're trying to build, ask yourself this. Are you packing your data efficiently to make the heavy lifting easier? Or are you just hiding the mess of bad measurement? Use parceling wisely, and I promise your research will be vastly stronger for it. Thanks for hanging out with me for this explainer, and happy modeling.